Hi everyone, and welcome to senseFly Academy webinar. I am Andrea, Training Manager at senseFly. Today, we will first look at some of the new features of our newest release, eMotion 3.5.0, including the export of the Agisoft PhotoScan project file. Consequently, we have specialists from Agisoft, Diana and Alexei, with us to show us how to process datasets with their software PhotoScan. Welcome, Diana and Alexei.
Hello, everyone. My name is Diana. I'm a product manager at Agisoft, and I'm here today with my colleague from Agisoft team, Alexei.
Hello.
We are glad to be invited by senseFly to join this webinar session and have this opportunity to introduce you to PhotoScan software workflow. Let's wait for our part of the presentation, and now, Andrea, I'm passing the word back to you.
Great, thank you, Diana. As you already mentioned, I'll be starting the session with the new features of eMotion and then passing back to Agisoft team. So the first new feature that I'd like to introduce is the beta level language support. With the newest release, we're now offering the translation to Chinese and Spanish. You can change the language by going into the options, choose local preferences, languages, select on the drop-down and click OK at the bottom. The second feature is the Smart Mission Resume, where the new part about this that it resumes at the exact same position as it left previously. So if it has left because you had to change the battery or there was another interruption of the flight and you resume the mission, it will go back to that exact same location and continue the mission from there. That means you have zero duplication of flight lines and image captures. Live air traffic data, the third feature to introduce. You can use now a UAVionics ping USB ADSB UAT receiver. It's a bit a long name, I agree. It looks like this, and it's going to be plugged via USB cable to your eMotion on your ground station, where it's best to set up the receiver to be vertically, not horizontally. It will then detect air traffic that is sending on those same channels within 15 kilometers radius of the working area and below 2,000 meters. So only within that range you will get feedbacks from planes or helicopters. Once connected, like you see here on this picture, on your eMotion, you will have an air traffic symbol where you can turn on and off the visibility of the icons of closer planes. Since this is a bit picture that where one doesn't recognize well the icon, I copied here from the user manual the description. So you get a triangle shape, which is your airplane or your helicopter. There is a white line extending from the front of the triangle indicating the speed. So the longer the line, the faster the plane. And the direction of this whole assembly here is the direction of travel of the plane. At the same time, we will have this panel here where it identifies the traffic and it gives us the altitude separation between drone and traffic. There are two levels of alert. Yellow, just warning, traffic. In red means there is really a danger of collision or you're just too close in airspace. So the yellow one appears if there are 45 seconds left until there is risk of collision, and red appears if there is only 15 seconds to react. Be aware though that not all airplanes or helicopters are sending their location via these channels, and therefore you still have to monitor the sky just by having an eye on it. Then, lower altitude landing procedure by changing the home waypoint altitude. In your home waypoint settings or on the screen in 3D view, you can change the home waypoint altitude, which by default is at 75 meters. If you leave it at 75 meters, the landing procedure and approach will be starting at 75 meters, as we all are used to it mainly. If you change the home way altitude to be between 50 to 75 meters, it will accordingly do the approach and the landing procedure at that level, for example, 60 meters. If your home waypoint is lower than 50 meters or at 50 meters, your approach will be done at 50 meters. Lowering that home waypoint altitude will ultimately also shorten the landing approach. You see, it's not the original length, it's gonna be slightly shorter. And with this, I'm going now into the Agisoft PhotoScan integration feature, where we will switch for that into eMotion. And actually, this integration happens, of course, after your flight when you do Flight Data Manager. So under Post-Flight, Flight Data Manager. Now I'm gonna do the procedure with a flight that has already been done. Didn't use my laptop, so I have to go from here. I create my project folder. I place it where I need it to be. Then I say next. I have to now, of course, manually go and select the BB3 file. So the flight log. The eMotion flight log is optional, so for right now I leave that away. Okay, we see it was an RTK flight with accuracy of 0.044 meters. So we're happy with our absolute accuracy, and then it will be asked for the images. I browse, select my image folder, say next, voila, and next again. So here we got 100% on the matching between geotags and images, which is perfect. And now we are about to select our outputs. So here you have now the option to create Dremel project files, but also create Agisoft project files. So we don't want all of this. We can leave the KML flight. Now clicking next. Voila. Now we just go into the open project folder and we see that we have here the Agisoft demo.psx file, which ultimately brings us into Agisoft PhotoScan's processing software. And with this, I'd like to hand over to Diana and Alexei to continue the presentation about their processing software.
So, thank you, Andrea. Let us talk about imagery processing in Agisoft PhotoScan software now. As Andrea already mentioned, the integration between EB Aerial Service System and PhotoScan processing tool gets pretty straightforward now, thanks to direct export of PhotoScan project file from eMotion. And the purpose of my part of the webinar today is to show what actually comes next after you have collected the image data and exported some, well, still unfamiliar PSX file from eMotion. To introduce you to photogrammetric processing with PhotoScan, I plan to discuss the following points today. First, briefly explain what a PSX file is and how to open it in PhotoScan. Then I will demonstrate the basic processing workflow to generate the targeted outputs like point cloud, digital elevation model, and orthomosaic. And also during my talk, we'll discuss the crucial issue of accuracy validation of the results. Surely you can ask the questions during my talk, and Alexei will try to answer as many of them as possible. And some time will be allocated for Q&A session after the presentation. Let's proceed to the first topic. A PSX file, what is it? Actually, PhotoScan software uses project concept to manipulate the data relevant to one dataset. Thus, a PSX file which you can export from eMotion is an initial file which allows you to start the processing workflow in PhotoScan. It already has all the survey data needed for aerial triangulation and spatial reconstruction of the scene. Those are source images, camera positions, accuracy information, as well as coordinate system indication. Let's see how a PSX file can be opened in PhotoScan software. This is actually a program window of PhotoScan. We should go to File menu and click Open button. Browse to the targeted folder where Andrea presumably has just saved Agisoft PSX file recently. Choose it and click Open. We see that all the images have been uploaded to the software, and we can inspect them if necessary in the photo view. And then switch back to the model view. Model view is used to show you all the intermediate processing results during processing workflow. We can also see cameras positions on the reference page of the program window. Those are X, Y, Z coordinates, as well as accuracy estimates for the data measured. We see that for this data set, all camera positions were measured with the accuracy of almost 2 centimeters, which is pretty high thanks to RTK system used by EB survey platform. Definitely, the accuracy of the input data matters significantly for the results of photogrammetric processing. That's why it's good to use an RTK dataset. Now we know what a PSX file is and how to open it in PhotoScan software. And before we proceed to basic processing workflow, let's see what preferences should be set in advance. We go to Tools menu and choose Preferences comment. In this dialog, what really matters for us today is GPU tab, because PhotoScan uses GPU acceleration to speed up processing. You should care about GPU device installed on the hardware system you are going to use for processing, since it will allow you to perform the whole processing as quick as possible. The second option, which I would like to mention today, is the language. Actually, you could switch between various languages of the user interface following your preferences. German, French, Italian are available, as well as Japanese, Chinese, or Russian. So for today's demonstration, I'm using English for all of us to understand it, and close the preferences dialog. Now, let's see what are the steps of the basic processing workflow. All of them are assembled, as you may guess, in the workflow menu. The first step in photogrammetric processing is aerial triangulation. In PhotoScan interface, the command is called align photos. The algorithm has several parameters. Accuracy parameter controls the quality of aerial triangulation. while pre-selection settings allow to reduce processing time. The values we now see on the screen are the recommended ones for a typical aerial dataset, the one you will export from eMotion. Let me skip detailed discussion of the parameters not to overwhelm today's audience with information at this introductory webinar. However, you're surely welcome to ask detailed questions if any, and if you feel that it's already important at this stage. All in all, you should click OK, but for us to save the webinar time, I have pre-processed the data in advance and now could open the results. Here you are, the results of the first processing step, the photo alignment step. As promised, in the model view, you could see the results. This is actually a sparse point cloud. It consists of 3D points whose projections were detected as type points on the images. For all of us to understand the language used, let me remind you that a type point actually is the following thing. During photo alignment step, PhotoScan searches for feature points on all the source images, something special on the images. Then the program automatically matches feature points between the images. A set of feature points from different images, which represent the same real scene point, is called a type point. And we see their representations in the model view. In some areas, we see that a lot of type points were detected, while in others there are just few of them. This happens, for example, in areas with high crops, like, let's see, cornfields in our case. Well, we have discussed sparse point cloud data visualized in model view, but actually it's not the primary result of aerial triangulation. What really matters is the estimation of internal and external camera orientation parameters. As for internal, those are camera calibration. Actually, you don't need to understand it deeply at this stage because PhotoScan performs auto-calibration procedure. Thus, for you, there is no need to care about calibration file for the camera used for the project. I just show you where it could be found, but it's not obligatory to inspect it at this processing workflow. As for external, those are camera position and orientation data, and you could inspect them in reference pane. We need to switch to View Estimates tab, and here you are the estimated camera positions, as well as we see PhotoScan has estimated your pitch roll rotation angles. Aerial triangulation completed. This is the first checkpoint for us to analyze the accuracy of processing. PhotoScan allows us to inspect errors of estimated camera positions. For this, we need to switch to View Errors tab of the reference pane and see both deviations for all the cameras and total error. Actually, by total error, PhotoScan means RMS error. We see that in our case, the accuracy is just 22 centimeters. Actually, we have to admit that it doesn't sound good enough. To make PhotoScan improve the accuracy of the estimates for all the parameters involved in bundle block adjustment problem, we recommend to run optimization procedure. To run it, we have an optimized camera button on the reference toolbar. In Optimized Camera dialog, we recommend to leave all the checkboxes as suggested by default and click OK. It will take around a minute for our dataset of 81 camera only. And as usual, I'm switching to the prepared results for us to continue the discussion. So once we are on Error tab already on the reference pane, scrolling down, we see that optimization procedure has reduced the RMSE down to 1.6 centimeter, which is pretty good. And it happens thanks to the RTK data involved, surely. However, I have to draw your attention to the fact that actually this figure indicates only how consistent the image set itself is. And as a result, it surely indicates the precision of aerial triangulation, but it's not the very figure we are interested in. What we are interested in indeed is how precisely our future model will be positioned in real-life geographical coordinate system. To validate processing from this perspective, we will need several checkpoints. It means that you should measure coordinates of several points around the surveyed area. For this dataset, 12 checkpoints were measured, and I'm going to upload a CSV file, actually a TXT file, with their coordinates into PhotoScan. To do this, I use Input button on the reference pane toolbar, browse to the folder where the necessary file is, and open it in Input CSV dialog of PhotoScan. Here it is important to make sure that the coordinate system has been indicated properly according to the measured data. In our case, it was VGS84 coordinate system, like shown on the screen. What could be mentioned here is that PhotoScan actually supports most of coordinate systems included in EPSG register. You also have the option to input description of any local coordinate system used in your project if there is a need to. So I have checked that all the columns were properly attributed, longitude, latitude, altitude, and click OK. Well, PhotoScan asks me to create instances of markers to upload the coordinates data. I choose yes to all. Switch to View Source tab on the reference pane, and now can see all the checkpoints and their coordinates uploaded to the markers section of the reference pane. Moreover, PhotoScan has actually placed the markers according to the data loaded into the PhotoScan. We see those flag signs on the sparse point cloud, as well as some markers were positioned on the photos. But for us to achieve the highest precision possible, we need to refine those marker locations. In order to do it, I choose the first checkpoint on the markers pane and filter photos by markers. Now in Photos pane, only the photos where the selected checkpoint is visible will show. I can click on the first photo, zoom in to the point of interest, and simply drag the marker instance to the position of the measured point. And I will need to repeat this action on all the photos where the marker is visible. and PhotoScan suggest me what those photos are. Actually, it is needed to repeat this procedure for all the checkpoints and for all the photos where the markers are visible. If the amount of checkpoints prevents you from refining the position on all the photos available, then it is recommended to place the marker at least on 5 images. But it would be even greater if you opt for targets usage in your project. By targets, I mean just plates with special signs on them. And those could be the signs like a circle with white and black sections, as well as a rectangular with white and black sections, or just a black circle against white background. The benefit of using such plates is that PhotoScan automatically detects such targets on the images very precisely, and thus there will be no need to adjust marker locations manually. So the procedure would be for you to place such plates on the ground before measuring the locations of the points. Let's imagine that in our demonstration case, I have refined the positions of all the markers, and I'm switching to the prepared project. So now I see that all the images have green flag. It means that the position of the marker has been refined there. And we switch to the arrows tab on the reference pane to inspect the deviations for all the checkpoints used in the project, as well as refer to the total error. Again, I remind you that this is actually IMS error. And we see that actually it's around 3 centimeters. It means that the accuracy of georeferencing of all future outputs, like orthomosaic, for example, will be of 3 centimeters. Having checked the accuracy of the data, you can proceed to generation of the target results. Of course, if you are satisfied with the accuracy achieved. And let's start with building dense point cloud. Even if it's not of interest for you per se, it is recommended to generate dense point cloud for every project, since it is a source for accurate digital animation model, which normally is required in such projects. The major parameter for building dense cloud procedure is the quality setting as usual. While ultra-high setting is appropriate just for some experimental data, the high would be the proper option for all the ordinary scenarios. So as usual, I'm switching to the prepared dataset. And in the model view, we could see the results of building dense point cloud step. Actually, this is the dense point cloud. It contains over 73 million points. Let me zoom in for you to be sure that those are points, not something else. So you see points, pretty dense. Based on the dense point cloud data, several products can be created. Let's see them in workflow menu. Those are polygonal model, mesh, tiled model for huge data sets, and digital elevation model. I assume that digital elevation model is of most interest to the audience today, so I go straight to demonstrating the procedure how to generate it. Pretty obvious that we need to check the coordinate system for our digital elevation model. In our case, I will leave it to VGS84 coordinate system, but actually at this stage you can change it to a new coordinate system, and PhotoScan will automatically calculate the transition from the original one to the new designated system. As mentioned before, the proper source data for accurate elevation model would be dense cloud. The alternative is sparse point cloud, which could be used for some preliminary estimates, but is not recommended for accuracy reasons. As usual, okay, and I could show you the results. This is a digital elevation model created for our dataset of 80 images. Once the DEM has been created, orthomosaic option is unlocked, and we could run this procedure. As for the parameters, I will focus on those two. The surface. For aerial datasets, it's recommended to use, it's normal, typical to use digital elevation model as the surface to project orthomosaic onto. And as for blending mode, mosaic is the most preferable option. And this is the orthomosaic for our data. I could zoom in for you to inspect it, to see how it looks like. You see, pretty fine. Well, all products which we have created so far will be stored in our PSX file and could be accessed later. You see them enumerated on the workspace pane. Alternatively, you could export any of them using the File menu, Export option. So export is available to any designated folder selected by the user. And the products could be exported in various formats to provide compatibility with CAD software or other post-processing tools. For example, dense point cloud could be exported as a LAS file, while TIFF is the most popular option for orthomosaic and digital elevation model export options. TXF might be convenient for polygonal model and contours export. Coming back to the project file, I should mention that all information about accuracy we have inspected in the first part of discussion. General survey statistics like survey area, time spent on different processing stages, as well as values of the parameters we have chosen at every processing step would be stored in our PSX file. However, PhotoScan can summarize this information and export it to a PDF file. To achieve it, we should choose Generate Report option from File menu. And I'm going to demonstrate how the report file looks like. So here we have the preview of orthomosaic generated survey statistics data. Next comes calibration data with all the camera internal parameters, camera locations, the estimates of camera positions, as well as information about our checkpoints used in the projects, and show a preview of digital elevation model. And the last are the parameters used at all the processing stages performed, as well as the time spent on each stage. Well, that's actually the end of the basic processing workflow I wanted to show you today. I hope it was understandable, and I tried to focus on the key aspects to generate quality results with PhotoScan based on the data captured with EB platform. All in all, PhotoScan has quite a number of advanced features, which time doesn't allow us to discuss today, but just by way of brief overview, let me enumerate some of them. First of all, with PhotoScan, it is possible to perform linear and profile and volumetric measurements. And furthermore, PhotoScan can process not only RGB data, but also data captured with multispectral cameras like MicaSense Radix, for example, or Parrot Sequoia camera. And based on multispectral orthomosaic, it is possible to calculate vegetation indices for precision agriculture industry. Today we have discussed only how to generate digital elevation model, while in fact PhotoScan allows to generate digital terrain model as well. It is possible thanks to automatic classification of points into ground class and the rest of the points. Further classification also possible, but only in manual mode, with support for standard point classes notation. Well, as for automatic detection of coded and non-coded targets, we have already mentioned this, and this sim lines option is indicated as a possibility to edit orthomosaic if needed. In our case, everything was so fine that there was no need to edit it, but sometimes some editing might be needed. So again, very briefly, I have enumerated some tools available in PhotoScan software. You are very welcome to visit our website. This is the starting page, and request a trial key just to test the software for 30 days. And for this testing stage, you could use various tutorials available on the website as well as study user manuals available for downloading from the website. Should any questions arise during your testing, please contact us via the form on the website, and our support team will try to guide you through the process and workflow depending on the project you are performing. So again, probably that's it I would like to share with you today. Let me pass the word back to Andrea to manage Q&A session, and Alex and me are still here. So if you have some questions to be asked right on the spot, please use the chat. Thank you.
Thank you, Diana, for that super good and detailed overview of processing with Agisoft PhotoScan. That is really helpful, I believe. Also, the type of results that you've been showing are super interesting for all our EB pilots. Good. With this, we go over to some Q&A session, and we'll check how many questions there are, and we'll answer some of them. And I think it would be good if we go right away with Agisoft related questions, since it's the last thing that we left off. And there is one, can we have a view on the orthomosaic on maize area?
Hello, it's actually Alexei, and I'll show you zoom to this area in AutoView. Just maybe. So actually you can see that the quality will be better if you have a better reconstruction of the surface. So in our case, we have used a digital elevation model. Here you can see the lines of the crops, and the orthomosaic is projected on this available surface. So practically here, I believe the result is quite good. So we don't see considerable artifacts. Maybe here just some kind of smooth blurred area. And maybe as an additional feature of AutoMosaic that Diana has mentioned about SimLine editing while we are waiting for more questions. So, for example, here on the AutoMosaic, we see the car that is moving along the road, and maybe on our final AutoMosaic plan, we do not need the cars on the road. So here we can use draw patch option and apply the most appropriate image without the moving object to the AutoMosaic. So I start to draw a polygon along the object that we do not need to see here, and then I use assign image option from the context menu. So here, for example, I can list through the different photos and select the one without the car. So then I need just to update the AutoMosaic and remove the shape that is patching our auto image. So the resulting image will be blended better. Here we've got just the preview of the source data. So that's how we can correct some unwanted areas or maybe some failures of the stitching operation. As I see the additional question about the surface model and the moving car here. So if we switch to the digital elevation model, we don't see the car here. So actually, that's because the elevation model is based on the dense point cloud that is generated according to the overlapping image pairs. So the car is moving, so it is not in the same location for every image pair, and PhotoScan will filter such noise for the final product. So we see some areas for the actual mod. So for the standing cars on the digital elevation model, but on the road with the moving cars, we do not see such artifacts. So, and another question that we see here is about camera calibration, whether it improves the accuracy of the result and if it's needed or not. So generally, we recommend to use the pre-calibrated information for the metric cameras that are calibrated in laboratory conditions. So if we go to the camera calibration window here, we can load the calibration information from different formats that are supported. But for the compact cameras, small digital cameras, actually, we believe that the calibration is not necessary, and you can just let PhotoScan to adjust the calibration parameters during the alignment stage and during the optimization stage. Usually that's because the digital cameras may have some moving elements, and in some cases, shake related to takeoff and landing may affect the positions of the lens system. So not every time you can reuse the calibration information between the different flights. So in general case, you do not need the calibration. You don't need to pre-calibrate the camera, and you should receive already good results after optimization stage with RTK system. So, and another question from Alejandro about the accuracy with no RTK system. So actually, if the onboard GPS device is just a common low accuracy device, and there are two general cases. One is georeferencing based on only onboard GPS, and in this case, the precision will be comparable to the accuracy of the coordinate measurement. So it could be several meters, for example, for simple drones of consumer grade. And however, even with the low accuracy on board GPS device, you can always use control points to improve the accuracy of the result. So in our project, we used only checkpoints to validate the accuracy, but if we don't have RTK system in this project, for example, we could check on some markers in the reference pane, thus using them in optimization process and georeferencing process, then re-optimize the camera alignment again, and this coordinate information for markers will be used for georeferencing. So in principle, it is possible to get comparable results with the ground control points, but not in every project you are able to take sufficient number of ground control points, and that's why RTK system is now getting popular, so you don't spend time and resources on gathering a set of ground control points like 10 or 20. So you can use only a couple, maybe 3 points for accuracy validation, just to confirm that the result is the result fits the accuracy requirements of the project. So while we are waiting for other questions, maybe I can show some measurement instruments based on digital elevation models that were also mentioned in advanced section. So we can start from linear measurement here. So the basic tool just for inspection is a ruler that you can find on the toolbar. So when clicking first time on the digital elevation model or automosaic, you get the coordinates on the point that you are clicked on. While clicking further, you can get the distance, the linear distance projected on XY plane and measure some linear distances here. So it's this ruler tool is just for quick inspection. If you need to measure several kinds of elements at once, or require some export of the measured result, you can use shapes. So here I'm drawing the linear shape, for example, and then I can measure it. So right-clicking on the shape element, I select Measure Tool, and here I see the measurement information, the coordinates of each vertex of this shape, the perimeter, actually the length of this element. Also, we have a profile tab here, so you can see that you can measure and inspect the elevation information along the drone shape, and also you can save this profile information in vector format, or to be opened and analyzed in post-processing application. Additional instrument for measurement is a polygon tool. So we can draw a polygon here, for example, around the building, and also click on Measure step. So we again get the vertex information, coordinates, the area covered, again the profile information along the drone shape, and also we have the volume measurement instrument here. So it's you can select between several options: best fit plane, mean level, or custom level. So here, for example, in the mean level, like average elevation of all the vertices, you can see the total volume, the volume above and volume below the selected level. So in principle, you can also save the shape report to the file and see in brief some general information about the shape here. So the overview with some index of the shape and the general information about it. So we see the next question is related to the DTM generation. And so to show it in brief, we get back to the dense cloud. So to start the digital terrain model generation, we need at first to classify the ground points. For this procedure, we need to use classify ground points option actually in tools menu. This feature automatically extracts the ground points and the noise points that can be filtered out from all the points in the dense cloud that is originally unclassified. So we have a set of parameters here. You can review a related tutorial on our website. So we set some adjust these parameters depending on the project, because actually we have quite a lot of questions if there is a best set of parameters that will fit all the projects. Actually not. You need to adjust the parameters according to the terrain type and the project. So if the result is not fitting your needs, you need to reset the classification and adjust the parameters and see how the result is getting better. So here, after starting the operation, as a result, you'll get the colored classes here. You can see that brown points are related to the ground, pink points are filtered as noise, low points they were called in the stub, and the white points, the gray points, are just unclassified original points that are not ground and that are not noise. So at this step, you can proceed again to the elevation model generation, but select from the point classes only the certain points. So we uncheck the noise, we uncheck unclassified points and leave only ground points for the model generation. So when we click OK, PhotoScan will generate the surface based only on the ground points, and it will produce the digital terrain model as a result. And also we have a question regarding the comparison between several elevation models in the same project. At the moment, there is no option to perform such analysis between multiple elements in the same chunk. However, already in the latest release version, it is possible to keep several digital elevation models or instances of the same class in the same project. So I just cancel this operation and show how it can be done. So for example, if we need to generate digital terrain model but keep digital surface model, at first you right click on the digital surface model here and uncheck set as default option. It means that now PhotoScan acts like there is no elevation model in the project. But when you generate another model here, you will get another instance of the same class. So for example, we can call it DTM. So switching between these two will allow you to review the different elevation models, the different instances of the same class generated using different parameters, for example. So I believe that at some step in the next updates, we'll be able to implement the comparison features that will allow to perform analysis for two elevation models or for multiple elevation model here.
Great, thank you, Alexei, for all the explanations.
Okay.
Or do you have more?
So,
yeah, there was one more.
Actually, I'm not sure if I understand the question about height model of the canopy, but I think if the question is about the measurement of the different vegetation type, then it can be only done like a measurement of the points on the digital surface model. So we don't have special analysis classification tools that will be able to extract different type of vegetation. But for example, with this profile measurement instrument, you can see here the elevation of the base level, and here you will see the elevation of the vegetation along the drone profile. So, and as alternative option, since we don't have the possibility to subtract one elevation model from another at this point, you can just export digital surface model, export digital terrain model, and use the post-processing GIS application to subtract one from another and get the height in the given area, for example. So I think that if there are no more questions, I'll pass in the word back to you, Andrea.
Thank you, Alexei. Thank you for answering all these questions and showing us so much more also of the software. Good. And with this, we end this senseFly Academy webinar. Thank you very much, Diana and Alexei, for showing us all of your PhotoScan software. It was really interesting and I think very helpful. Thank you very much.
Thank you, Andrea. Thank you for a chance to introduce PhotoScan to the users of EB system. And yes, we are open for further questions, either right now via the chat, which I believe will be still open for several minutes, or via email. You are very welcome. Goodbye.
Bye.